Hi everyone, it's Math with AUB. Let's see another elegant application of differential equations in daily life. Our question reads as radium decomposes at a rate proportional to the amount present. Radium decomposes at a rate proportional to the amount present. If 100 milligrams set aside, now there will be left only 96 grams after 100 years. After 100 years, 100 years hence, find how much will be left after T centuries from the time when the radium was set aside, how much will be left after 2.58 centuries, and also find the half-life of the radium. Let me read again. Radium decomposes at a rate proportional to the amount present. If 100 milligrams set aside, now there will be left only 96 milligrams over after 100 years. 100 years hence, find how much will be left these centuries from the time when the radium was set aside, how much will be left after 2.58 centuries, and the half-life of radium. Simple it is. The rate of the decomposition is proportional to A stands for amount present. A stands for amount present. T the time. T the time is proportional to the amount present. Rate of change. Rate of change means decomposition, composition, increase, decrease, decay, growth, both are present in that. Rate might be negative, might be positive, it depends upon the situation. Amount present, decomposition rate is directly proportional to the amount present. Whenever proportionality sign is run, we introduce a constant dA over dt is equal to k times A. A. The constant we have to determine utilizing the given conditions. First solve this equation. Separable differential equation it is, or linear. You can solve it both method. Let me apply separable variables. Separate the variables. I have dA over A. dA over A and k times dt. Integrating both sides with respect to the independent variables. dA over A is k is constant k times dt. It is ln A is equal to k dt means t plus c. Simple integrating, simple separable differential equation it is. We are interested in E. To get rid of ln, taking E as a base. Inverse of ln x is Ex and inverse of Ex is ln. To remove ln, introduce E. E as a base, E ln A. E raised kt plus c. E ln cancelled out. So I have A is equal to E raised kt plus c. kt plus c. I can write this one as A is equal to E raised kt times EC. The tiny fact of the exponent. It can be written as this one. E raised c is a constant. Let me introduce a constant C1. C1 initially 100 milligrams set aside. 100 at initially A is 100 milligram. E raised k t is equal to 0. Initially means at t is equal to 0 times C1. We can easily determine k. C1 constant. It's E raised 0 is equal to 1. Any quantity raised to power 0 is equal to 1, provided that A doesn't equal to 0. A non-zero quantity having 0 power is always equal to 1. So I have C1 is equal to 100. C1 is equal to 100. C1 is equal to 100. Okay. So I have, let me manage value of C here. A is equal to 100 times E raised kt. E raised kt. E raised kt. After a century, after 100 years, 96 milligrams only left. After 100 years means 1 century. 1 century. So I have A is equal to 96 grams left. 96 grams left. after a century, 10 e raised k times 1, e raised k times 1. Century, 100 years we have taken 1 because in case of half-lives, the duration is big enough, that's why 1 century have been taken as 1. So I can easily find the value of ek, 96 over 100 is equal to e raised k. I have e raised k is equal to 0.96. Let's see. Here we can utilize e raised k. A is equal to 100 times e raised k t. Instead of e raised k, I can write 0.96. So A is equal to 100. E raised k means 0.96 t. It is the amount after t centuries. It is the amount after t centuries. It is the amount after t centuries. Can I? T centuries. Okay, let me erase from here to give you a good idea. I have now what is the amount after 2.58 centuries, and I have also find half-life, time for the half-life. Let's see half-life of the radium as well. So I have A is equal to 100 times 0.96 raised t after 2.58 centuries. After 2.58 centuries, t is equal to 2.58. A is equal to 100. 0.96 t means 2.58. 100. Let me utilize calculator. 0.96 0.96 0.96 raised 2.58. It's equal to 100. 0.900. It is 0.900 multiplied by 100 for you. It's equal to 90. It's equal to 90 milligrams. 90 milligrams means after 2.58 centuries, only 10 milligrams have been decomposed. Only 10 milligrams have been decomposed. The remaining amount is 90. The remaining amount is 9 mg after 2.58 centuries. After 2.58 centuries. Okay, cool. Now let's find half-life of radium. Half-life. What we have amount? 100. Now we have A is equal to 100. Rate is 0.96 raised t. We have to find half-life. Half-life means half. 100 instead of 100, we must have 50 to find half-life. Half the amount. We have half the amount. 50 is equal to 100 raised 0.96 raised t. It will become 50 over 100 is equal to 0.96 raised t. It's equal to 0.5. 0.5 is equal to 0.96 raised t. Now our variable that we have to determine, it is present in the power. To drag the power down, introduce ln both sides. I have ln 0.5 is equal to ln 0.96 raised t. So power will become coefficient ln 0.5. ln 0.5. Is it good? Good. Don't change anything. Ln t times ln 0.96. T times ln 0.96. Solve 40. It's our going to be final answer. I have ln 0.5 over ln 0.96 is equal to t. A tiny use of calculator leads us to result. Let's see. ln 0.5 is equal to how much? Negative 0.693. ln 0.96 is equal to negative 0.04008. Let me write 41 is equal to t. Minus cancelled out. So 0.693 divided by 0.041. Okay, cool. It's equal to T is equal to 16.902, means almost 17 centuries. After 17 centuries are 1700 years. 17, this is half life of radium. This is half life of radium in our case. That's my tiny effort to give you to share with you how to solve daily life problems using mathematics. Most people ask where mathematics has been used. Let's see the applications of mathematics, especially differential equation. It's all by itself next.